Hey Codsaurs, my name is Dr. J and welcome back. Up to now in your programming endeavors, you've only had a few commands available to you. Commands like move the dinosaur forward, make him turn right, and perhaps change the color of your pen. Now today we're going to learn about functions, so that you can create your own commands. And with these new commands, we're going to open up a whole new world of automating your favorite dinosaur into drawing amazing diagrams. So stay tuned. So up to now, you've only had a few commands available to you. Commands like move forward, turn left, turn right, pick up the pen, go home, change color, these kinds of things. Today we're going to learn about functions, and with functions we're going to be able to make our own commands. But before we learn how to make our own functions, let's code up the example from the last episode where we were able to draw a square with a certain size. So here we go. So there are our lines to draw a square. We've got 13 lines of a program here to draw a square of size 50. So what would we do if we want to draw two squares on the screen? Well, we could simply draw this first square, then pick up the pen, move to the new location, put the pen back down, and then copy and paste those same lines and make him draw that square in the new location. So let me do that. So here's our final program. This first section here draws the first square. Then we move our dinosaur, pen up, move the forward 100, pen down, and then we do that exact same code up there again to draw the second square. Notice how I've used comments here to explain what my program's doing. To make a comment, you use the double slash symbol, and then everything after that double slash symbol gets ignored, so you can leave a comment after that. Comments are great for reminding yourself later what your code is doing, but more importantly, they're useful for other people who are trying to understand your program too. So do try use comments as much as possible. So while these comments were nice, what was not nice is that we had to copy and paste and replicate a full 8 lines of code. They're identical over there and over there when we're drawing these two squares. In addition to duplicating this code everywhere, what happens if there was an error in our initial program? We now would have copied and pasted that error, duplicated that error into multiple places. And what more, what if we wanted to draw hundreds of squares? Well, then we're going to be copying and pasting a lot of code. It's going to very quickly become unwieldy. We won't know what's going on in our program, and certainly no one else will. And finally, what if we wanted these two squares to be different sizes? Notice that both of them are using that global constant size. If we wanted them to be different sizes, we'd have to have different constants, and we'd have to go change all those lines of code again. We seem to have come back to square one. So what can we do about this? Well, this is where functions come to the rescue. Wouldn't it be nice if we could create our own command called square, and whenever we call it, our dinosaur just draws a square at his current position? Well, that's exactly what functions offer you. A function is simply a collection of lines of code that you can give a name, and then that name is available to you as a new command. So let me show you how to do that. So to create a function, we simply use the word function and follow it with the name we want to give to our function, and then we put empty parentheses after that. Following that, you'll see there are these two curly brackets, this one over here and this one over here, these curly brackets. And between those curly brackets, you'll put all the commands that you want to be executed when you call that function. So we've created our function here. We aren't actually using it yet. All we've done is told the system that we want this function or this command to become available. We now need to use this function. And that's as simple as replacing our original lines of code that we're drawing squares with the name of our function. So here you can see I've replaced our original long line of 8 lines of code with one call to square and a second call to square here. Look how much neater our program's looking. And of course, if you run our program, we end up with exactly the same thing because all we're doing is drawing the 2 squares. So with the function, we have already solved 2 of our earlier problems. We no longer have to replicate tons of code every time we want to draw a new square. And secondly, if there were any errors in our square program, well, we'd now only have to go fix it inside the function itself, not in all the places we had copied and pasted that code. Our only remaining issue is, what if we want to draw squares of different sizes? Our function is still making use of our constant called size, so we can only draw squares of size 50 at the moment. Wouldn't it be nice if we could give our function, our square function, some more information when we call it, so that it knows what size we actually wanted to draw the square? Now, where have we seen this idea before? That's right. In our forward command and our turn right command. In the forward command, we passed in a size, that was a number of how many centimeters we wanted to move forward. And in our turn right command, we could pass in a number, in this case 90, to tell it how many degrees to turn to the right. So how do you think we're going to be able to pass information to our own functions? It's obviously going to be something to do with those parentheses. So let me show you how to do that. This process is called passing a parameter to your function, and it works like this. So if you look at our function now, the parentheses are no longer empty. I've put the word desired size as the name of the first parameter we want to give this function. Then what I did is in the fd command, I replaced the use of our constant size with this new parameter desired size. I've done that 4 times there. And so the only last thing we need to do is we now know our square command actually needs a size passed into it. So I'm going to actually pass the size of the square that we want drawn. I'm going to do 2 different sizes here, and I'm going to execute that. And you can see now we've got 2 different size squares, one of size 50, then we move forward 100 centimeters, and we drew another one of size 30 up here. And voila, you now have a new command that you created yourself. You can call the command square and pass in the size that you wish, and your dinosaur will draw a square on that spot where he's currently sitting. Kind of nifty, no? Now you can get really creative. But before we do that, let me tell you about another command that you might find useful. It's a command called goto2d, and it takes 2 parameters this time. The first parameter tells you how far left and right you're going to be moving the dinosaur on the screen, and the second parameter is going to tell you how far in the up and down direction to move that dinosaur. The dinosaur will jump directly there and won't draw a line behind it. So let me use goto2d in this program to make it a lot neater. So because I used the command goto2d, we no longer had to have the code that picked up the pen, moved the dinosaur and put the pen back down. You can see how much shorter the program's become. I've told it to go to 0, 0, which is the center of the screen, and the dinosaur will then draw a square of size 50 there. It's then going to jump to the position 0, which is 0 on the left-right direction, so it's still the middle of the screen in the left-right direction, but it's going to be 100 centimeters up on the screen, and it's going to draw the smaller square of size 30. So you can see with the use of functions, our program is becoming more and more tidy. You can almost tell what the whole thing's going to do just at a glance. And now that we have these 2 new commands at our disposal, goto2d and our own handcrafted one called square, let's start getting creative. Try and keep up with what I'm typing here. So all I did was moved or changed the pen color, white, red, and green. I then jumped to 3 different spots on the screen, and I did the exact same thing, drew a square of size 10, 20, and 30 in each of those 3 positions. And that's what's drawn this little pattern here of the larger and larger squares in 3 locations in 3 different colors. You can see the red square, where the second parameter was 100, is 100 centimeters up the screen, and the green square, which is the first parameter, minus 100, well, minus is in the negative direction from the center along the left-right direction. Isn't it cool how you can draw so much with so little code? But what's even cooler is you can make functions that call other functions that you've already created. So let's try that. In this particular instance, you'll see I've drawn the square of size 10, 20, and 30, and I've done that 3 times. You know how much I hate duplicating code. So how about we create a function? So I'm going to create a function called squares pattern. It takes no parameters. There's our empty function. It's got no commands in it at the moment, but you can see the curly brackets are ready to contain the commands we want. And I'm going to take the 3 commands of drawing the square and stick those into that function, and then I'm going to be able to simply replace our 3 locations where we were drawing 3 squares, and replace those 3 lines each time with just the word squares pattern. I've got some funny symbols in there that I need to get rid of, and there we have it. The program is much shorter, but it does exactly the same thing as before. And in fact, let me tidy up. We don't need these comments anymore because you can pretty much read what the code's doing. So I'm just going to replace a few of these. And maybe I'll do one more for effect. Let's add a blue set of squares at position 100. So this is going to be off to the right. And we can get even smarter still. What if we want to specify the color that the squares pattern should be? Well, try it for yourself. Press pause now, and then I'm going to show you how to do it in code. Right, so it's going to be quite simple. We're going to create a parameter that we can pass to our squares pattern. Let's call it desired color. And we're going to call set color, but instead of calling it with a string with an actual color in it, we're going to put our desired color in there. Just like when we were moving forward by the size, we are now going to be setting color to that desired color. And then our program becomes substantially simpler. I can just move these colors to their respective callings where we called our command. And look how much shorter our computer program is getting. But not only is it getting shorter and neater, but we can do cool things like this now. Suppose our squares pattern, we didn't just want 3 squares, we want 5 squares. Well, I've just had to make a change of 2 lines of code, and our diagrams are becoming really creative and elaborate now. Okay. We're getting a bit carried away now, so let's stop there. For homework, try create some of your own functions that create some interesting patterns. And if you're extra creative, make sure you create some functions that use other of your own functions. And on that note, this is Dr. J signing out. See you next time.